Great to be here. It's a pleasure. Today we're going to talk about the application layer of the Interchain and how CosmWasm version 2, which we released earlier this year, is powering the most advanced IBC applications. I'm Simon, Managing Director of Confio. I work at CosmWasm development, maintaining that piece of software for 5 years now. It's a pleasure to be here, the fourth Cosmoverse that I'm attending, which is pretty cool. I've seen all of them. So I've been around, trying to improve the developer experience when it comes to application development, because for us it got pretty clear early on that the Cosmos SDK alone is not enough to build feature-rich and flourishing applications. So a quick recap, what is CosmWasm? CosmWasm is a second-generation smart contracting framework for building multi-chain applications. It's a piece of open source software, so we're not building a chain, we are not launching a token, nothing like that. We don't want CosmWasm to be successful on our chain, we want CosmWasm to be successful on all of your chains. And shout out to Robin for this phrase, because it's so much cooler and describes what CosmWasm is so much better than something like Alt-VM. So CosmWasm and its place in the modular stack. Quick overview, we have a lower level in a blockchain where blocks are produced with something like Comet BFT, the Tendermint consensus. Now we are entering a world where layer 2 solutions are getting more and more popular. So this is pretty much the lower level block production. Then we have a Cosmos SDK based application on top of that, which is the standard modules. We have Go IBC implementation in Go there. We have your custom modules that you write for your chains. And then there's a whole suite of projects that make the CosmWasm runtime available in your chain. And then on top of that, the green layer, this is where CosmWasm contracts live. And those contracts, they are created, uploaded, changed, modified, iterated on while the chain is running. So this whole orange area that you see there, every time you make any type of even the most simple changes, the most simple fix, the most simple feature addition, you need to recompile your blockchain. It's most likely going to be breaking consensus. So you need to deploy new versions of your software to all of your validators, to all of your node operators, and anyone who has done that a couple of times in the past knows that this is a bit of a pain. So you don't want to do that for every single improvement of your application. So we have this layer on top, this green one, that just continues running no matter what's happening below. No matter which version of the Cosmos SDK you're using, no matter which patch versions are needed below the stack, your application keeps running and you can upgrade it as often as you want without asking your validators. So that is the application layer we're talking about. A few basic concepts for CosmWasm, why it's interesting. It's based on WebAssembly, which is for us a way to not reinvent the wheel. We have a great specification that is driven by giants in the industry that is battle-tested for browsers. It's fast, we have near-native execution speed, it's formally specified. We get improvements on the specification all the time, so a lot of people are working on that. We don't need to do that ourselves. We get improvements of optimizers, of runtime, of debuggers for free, and we can focus on what we want to build with it. So that's pretty cool. We built our smart contract with Rust. It's a popular programming language, especially in the blockchain ecosystem. It has always had, and especially when we started, the best-in-class WASM compiler. So that's a strong plus for us. It has a large ecosystem. You can use all of the crates that you have in crates.io in your contracts. You can just import them. It's Rust contracts. And there's another point which I did not write down because it might be a little bit controversial, but Rust enforces discipline. And I think that's a good thing if we are working with other people's money. We built on the actor model, which is a way for us to separate concerns. We have contracts that send messages between each other instead of calling each other directly, which avoids this whole class of reentrancy attacks. And this model maps very nicely, not only between contract-to-contract communication, but also sending messages between the contracts and the Cosmos SDK, which is also based on messaging. We have a built-in upgrade system. So every time you upload a contract to your chain, it's pretty, chances are pretty high that this is not going to be the final version of your software forever. There will be bugs, there will be improvements needed, there will be all those little things, and there is a standardized migration system that allows you to upgrade the contract in a safe manner, in a standardized manner, such that the entire ecosystem knows, okay, this is how we do it, this is how we can verify who has authority to upgrade something, and if something is immutable or not. It can be immutable if you want to, but our advanced users use the upgrade system. What we have done, and this is pretty much one of the biggest feedback that we got, is a lack of docs. So what did we do? We did all kinds of approaches to documentation, hiring people, having external contributions, doing this and that, and doing it small and a little bit here and a little bit there. But it got nowhere until we said, okay, full stop, we need a completely different approach, and this is how we came up with Summer of Docs. So what we said is, 4 months in the summer of 2024, this summer, we do 4 months of documentation work. So no single feature is expected from any developer in that period of time. That is our work, that is the focus, that is the feature, that's the priority for the entire CosmWasm team. So we have 10 core developers writing that documentation. The people who wrote the libraries also wrote the documentation. And yeah, it worked quite well. We have it live. It's updated to the latest version of CosmWasm, CosmWasm 2. So have a look at that. And now I want to talk about what we did pretty much this entire year, the latest and greatest improvements in CosmWasm 2. So how it is different from the CosmWasm that you might have played around with 2 years ago. Because, yeah, a lot of great things changed, especially when it comes to connectivity to IBC. And, yeah, you can build even greater applications with that now. So, talking about IBC, CosmWasm has always been, and pretty much since the beginning of IBC, been able to connect contracts with standard IBC protocols and custom protocols. So you can do standard things like ICS-20 token transfer, NFT transfers, interchain accounts, interchain queries. But what you can also do is say, okay, I have 2 different contracts on 2 different chains, and I want to have an application-specific IBC protocol. So this is what IBC has been built for this general message passing between 2 endpoints, and this is what CosmWasm allows you to do. And yeah, not only the simple stuff that everybody's doing. We improved message transfer, so which is like the most popular and most important message type in the IBC world. We have the memo field now, which gives you all the access to packet forward middleware and some other improvements there. And we will be working on ICS-20 version 2 as soon as it comes out, such that a contract developer has easy access to the latest version of that protocol, which, yeah, is obviously pretty important. This is an advanced one. We have the option and this is really for custom protocols, the option to do optional and asynchronous acknowledgements. Optional acknowledgements is pretty much the idea, yeah, you have a packet that is sent, that is received, but the recipient does not create an acknowledgement for receiving that. And there are protocols, and you can build protocols where this is perfectly fine. You send messages you don't want to hear if they arrived or not. Maybe your application does not care. And you can do that with optional acknowledgements. But the second step then is you have asynchronous acknowledgements. And asynchronous acknowledgements is the ability to receive a packet, process it, not write an acknowledgement right away, but a few blocks later, maybe even in a different transaction in the same block, you create the acknowledgement asynchronously later on. And that allows you to do things like implementing packet forward middleware in CosmWasm contracts, as well as interchain query long polling in CosmWasm. Interchain query long polling is pretty much the idea you send a query over IBC to some data source, and the query result is not yet available, but it might come in a few seconds. So you might, for example, go to drand and say, yeah, I want to have this random beacon round number XYZ, but that is only going to be published in 10 seconds. So you don't get an answer right away, but the moment it comes in, you get the response for your interchain query. And this is what you can do with asynchronous acknowledgements through the advanced IBC interfaces in CosmWasm. We have support for IBC callbacks. And that is pretty much package delivery notifications. So there are two types of package delivery notifications. One is, okay, I'm the sender of a packet, I send it somewhere, I get notified when the packet was delivered and everything went smoothly. And the other one is, okay, I'm the recipient of tokens, for example, and when I receive tokens, I might want to process them, or I might want to send them to another place, or do some staking, or whatever you can imagine with that. So that is possible with IBC callbacks. This is implemented in CosmWasm. I don't think it's live on chains yet, but we are getting there. IBC callbacks, if you worked with IBC hooks before, that's pretty much a more standardized, more generalized version of IBC hooks. So it's pretty much solving the same use cases. We have support for IBC fees, which is going to be quite important as the IBC ecosystem is getting more and more expanding and more interesting to attack when, the whole question of spams come in. Because if you have a general purpose communication platform between two entry points that is completely permissionless, okay, there's some script kiddie who thinks, okay, it's fun to send some random messages over this channel that are complete nonsense and just polluting the entire communication line. Maybe they want to play with your chain, maybe they have a financial incentive to do so. But with IBC fees, we can make sure that this kind of spam is going to be expensive. And the IBC relayers get rewarded for the work right in the protocol. So we have that in the latest version of CosmWasm, and you can use it pretty much from your next project on. CosmWasm is not just a virtual machine that lives somewhere high in the stack and does its things in the sandbox. It is very, very tightly connected to the system that is running on top of. So we can, with gRPC queries, query into all the modules that you have in your Cosmos SDK chain. With any messages, you can send any type of custom message to the chain, no matter if Confio guys have that implemented or not. You pretty much just say, here, this is the message, the contract knows it, the chain knows it, only the two components need to agree, and then it's just routed through the stack to make sure it's going to be executed. So we had that before. With CosmWasm 2, this is much, much, much more streamlined, standardized, beautiful, and we got rid of the Stargate name, which never made sense in the first place. We worked a lot on efficient storage because the applications that we have were getting more and more advanced as CosmWasm was out there. People came up with more and more complex ideas what to store in their application. A large critique was around JSON encoding in storage, as well as how we encode keys in storage to make sure as the application is growing, things don't get overly slow. So we have a second encoding scheme in CosmWasm 2.2, which is out in a bit, which is message pack, which gives you a binary encoding for all of your message types without you having to do anything as a contract developer. It's pretty much the same Serta development, Serta encoding, but gives you a binary representation. It's much more compact, but it's also much easier to encode and decode. And we are working on a new storage library that is going to be the successor of CW Storage Plus, which is called Story. And with that library, we take a lot of the learnings from working with CW Storage Plus and building something that is really focusing on the application with the highest demand, that is more composable, that is more encoding, space efficient, and that's going to be much more maintainable in the long run. We improved the handling of submessages, so that's this whole idea of contracts sending a message and getting replies. So we have error messages in replies, which was like one of the biggest feature demands for CosmWasm 2. So we know that that getting an error message that is just some code space and some number does not really help any developer. So we now have error messages in a way that does not sacrifice on determinism questions. So we know the error messages that we get always have the exact same string representation in all cases, which is a major achievement for developer experience. And we have the ability to add payloads to submessages, which allows you to say in the code that where you create the submessage, you add some extra data, some extra information, send the message out, get the reply, and have that extra information available, which saves a lot of storing to disk and then reading it again in cases where you don't want to persist data. We have new cryptography in CosmWasm 2, so signature verification is now, in addition to SecP 256K1 and ED 25519, we also have the R1 curve, which is the curve that you need to do passkey verification. So that has been highly requested by all the folks working in this area of account abstraction and wanting to do things with keys that are maybe in your watch, in your phone. So you can use those for your applications. And this is one of my favorites, BLS 12381 allows you to do derent random beacon verification, so you can verify those beacons right on the chain very, very efficiently, something like 10 to 20 times faster than doing that verification in WebAssembly. And you can verify Ethereum block headers. So if you're interacting with an Ethereum chain and want to verify some state there, then this is the way to go. I heard Union is using that already. So another big feature that we are working on right now, that's a little bit in the work in progress, is mass migrations. When we designed the code and instance system of CosmWasm, we pretty much thought of one contract address as an instance that has a team behind it and that is pretty much very well maintained, and we have a small number of instances. But it turned out that as the usage grew, we have systems where people use factory systems with a lot of different instances. So for example, you have a DAX where every pool is its own contract. So we have a lot of instances, and people are getting a little bit nervous when they think about, okay, if I have to do a security upgrade in the code, then I need to migrate all of those instances on my ledger and create a single transaction for every 5 instances or something like that. So We are addressing that. We have a new numeric versioning schema, which gives you migration versions 1, 2, 3, 4, 5. Very simple, linear, no somewhere, no nothing, because you only migrate linear. That allows the system then, in case the migration version did not change, to skip the migrate call in the contract, which makes the whole migrate step much, much, much more gas efficient. And that is recommended for cases where you have security patches that don't need any state changes or any other interaction. And that is a preparation for mass migrations, where suddenly in one transaction you cannot only migrate one individual instance, but you can say, okay, I take this 100 instances and I want to migrate all of them to the latest version of the code, and I do that in one step, in one transaction. It's atomic, and you only have to click through 100 pages once on your ledger. That is the end of my presentation. Thank you very much. I wish you happy building with CosmWasm. The application layer of the Interchain. Find me at Hackmoss. We are going to have a lot of fun this weekend building. Yeah, thank you very much. Cheers.
Thank you very much, Simon. Yes, our